Alright, this is video 4. The date is November 13th. This will be a warm-up. But yesterday we learned about the general velocity basics. What's the velocity formula? What does velocity tell you about an object? Today we're going to be looking at graphing. So using your formula, that's kind of it. V final minus V initial over time equals acceleration. Solve for the acceleration from 0 to 4 seconds. So we only want to look from here on. So here's your V initial. Make your list. V initial equals 0. Here's your V final, and that is 30 meters per second. Time is 0 to 4 seconds, so the time change is 4 seconds. And plug in your numbers. 30 minus 0 over 4 seconds equals 30 meters per second over 4 seconds equals 7.5, and the units are meters over seconds divided by seconds, meters per second squared. That's our units for acceleration. For today, determine the acceleration from a velocity graph. A velocity graph is a distance over time graph. Practice reading acceleration graphs, so now this is velocity over time. And review 2 situations of constant acceleration. Brief review from yesterday. Slope is the rise over the run. Positive acceleration means an object is speeding up. Negative acceleration means an object is slowing down. Zero acceleration means an object is not moving, or it's moving with constant speed, like 60 miles per hour down the highway. So this is your basic idea. Do you understand how the slope of a distance over time graph relates to the velocity of the object? So on your page, pretend this is your book. This will be on page 33. I want you to draw 3 graphs with room for notes on the side. Okay, we're going to fill these up. But this is our first graph. Pause the video at any time if I go too fast. But I want you to draw the following. This is a review. I want you to draw an object that's moving away fast, coming closer fast, stationary, and away slowly. So we have words like fast, fast, and slowly. How does the slope relate to the velocity? So draw your graph as one consistent line and tell me what you think. Here's the answer. Away fast means distance is increasing quickly, steep slope. Closer fast. Stationary means it's not moving, no change in distance, and then away slowly. So in summary, steep slope equals fast. Flat slope equals slow. No slope, well, that equals stationary, not moving. So now our next graph. This is our basic idea. Proficient. Determine the acceleration of an object given a velocity distance over time graph. So first questions, draw this line. By the way, on the graphs that you're drawing, no numbers. Just do distance and time. Draw this line for me. And I want you to tell me, is this line showing acceleration, yes or no? Here's the answer, and this confused everyone today. The answer is no acceleration. And call this line 1. No acceleration because look, at a rise over the run, got a half meter in 1 second. Over here, it's a half meter in 1 second. half meter in 1. This is constant velocity equals 0 acceleration. On a distance over time graph, a straight line means velocity is constant. So let's do line 2. Let's call this line 2. And I'll do it in blue or red. Okay? Let's say it starts here and it travels half a meter in 4 seconds. Okay? So it'll be V1. And then for V2, it travels 1 meter in 2 seconds. V2. And then V3 in dark green, oh, it travels super far. So look at our velocities. The definition of acceleration equals changing velocity. So can you see how our distance over time is changing? So this would be acceleration, changing velocity or increasing velocity, specifically right here. The slope is increasing velocity. On a distance over time graph, acceleration would be like, this would be negative acceleration, and it's slowing down distance over time. By the way, at time 4 seconds, what's the distance? Well, if you count up here, at time 4 seconds, the distance is a half meter away. We're going to use the skill a lot. At this time, what's happening when you're reading the graph? Next graph, last one. I want you to draw this with no numbers. It should just be velocity over time. And I want you to draw the lines nice and straight and with the letters right by them. So pause the video and draw that. Here's how I want you to label them. This is now an acceleration graph. It's velocity over time, velocity in meters per second. Right, so this is velocity. I just made it worse. This is a velocity over time graph. At A, quick note on the top of your graph. You can write this. This is acceleration graph. Slope on a velocity over time. Slope on a velocity over time graph equals acceleration. So A, this is easy. Well, that's a positive slope. That's positive acceleration. Or increasing velocity. So you can see that velocity is going up and up. Right here it's a little bit, and here it's more, and then here, and all the way up at the top it's moving at 2 meters per second. So positive acceleration, increasing velocity. B, 0 acceleration with constant velocity. It's traveling a constant 2 meters per second. C, well, getting easier now. Negative acceleration or decreasing velocity. Negative. And D, so you can see the line down here. D is 0. It's a flat slope, acceleration, and not moving, right? Or it's moving a constant 0 meters per second, not moving. So let me ask you a quick question. I'm going to clean all this up. So if you need to finish writing this down over here, pause the video. But I'm going to clean this up and ask you a question. At time, let's move this so you can see. At time 5 seconds, what's the velocity equal? Write down what you think. Pause the video. Think about it. Here's the answer. At time 5 seconds, the velocity is, well, 1. V equals 1 meter per second. Next question. What's the acceleration during the first 1 second? Part A, what's acceleration equal? Make a list. What's your V final? What's your V initial? And what's your time? Well, my V final equals 2, right here. my v initial equals 0, and my time is 1 second, so 2 minus 0 over 1 equals 2 meters per second squared. All right, there is a quiz on the website. It's on the Velocity tab, Assessments, Graphing Quiz. Take your shot at that quiz, and here, I'll just do the answers right now. Here's the answers to the quiz, super fast. If you take the quiz, here are the answers. First one, this is what your graph should look like. Fast, slow, no movement, getting closer slowly. That's basic. Proficient, this is constant acceleration. Right? We're moving 1 meter each second, constant slope, 1 meter each second. So constant velocity equals 0 acceleration. To do the acceleration at 2 meters per second, well, in the first second you go 2 meters. In the second second you would increase, so you'd be up to 4 meters per second, 1, 2, 3, 4. And in the third second, you'd accelerate another 2, so it would be 1, 2, 3, 4, 5, 6. So you see this curving slope. On the last graph, ooh, what was it asking? During A, I'm going to pause this, let me check. Okay, sorry, I got it now. So the question is, at 4 seconds, what's the velocity? V equals, you need your units, 1 meter per second. B. Velocity is increasing because it's accelerating. V is increasing. And C, both C and E have 0 acceleration, but E is not moving, and C has constant V of 2 meters per second.